Section 8.5. Today we are going to be looking at multiplying and dividing radical expressions today, and we're not going to get overly complicated with the dividing anyway. Just going to look at single terms in the denominator when we do the division of radicals. Multiplication one's a little bit more complicated, but as long as we remember to FOIL, we should be okay with multiplying radicals. So we're going to multiply radicals, we're going to rationalize denominators with one radical term, and then we're going to leave it kind of with just those first two objectives today. So when you multiply radicals, multiplying radicals is really just like multiplying polynomials. We multiply binomial expressions by involving radicals by using the FOIL method. And we've talked about FOIL method forever from section 5.4. So if we're going to multiply using the FOIL method, remember the F means first. So first times the first. 2 times 1 is equal to 2. Outside. 2 times radical 5 is 2 radical 5. What's on the outside of the radicals gets multiplied by what's on the outside of the radicals. What's on the inside of the radicals gets multiplied by what's on the inside of the radicals as long as they have the same index. I stands for inside. Radical 3 times 1 is radical 3. And L stands for last. Radical 3 times radical 5. 3 times 5 is 15, so that's radical 15. Now you do what we talked about yesterday as far as adding in and combining any like terms. Everything seems to be simplified. We've got radical 5, radical 3, and radical 15. None of those can really be put together. So you circle it and move on. You're done. Next one. 4 times 4, 16. 4 times negative radical 5, so it's negative 4 radical 5. Radical 5 times 4 is 4 radical 5. Looks like those are going to take each other out. Minus radical 5 times radical 5 is radical 25. Middle two terms cancel each other out. That gives me 16 minus radical 25 is just 5. We would have to simplify it. 16 minus 5 is 11. There's our solution, FOILing. The next one, it clicked a little bit too much when I put this in here, but the question itself would have said radical 13 minus 2, and that quantity squared. Remember, when you square something, it's like taking it times itself. So we rewrite it out, and now we FOIL. Radical 13 times radical 13 is radical 13 times 13, which is 169, minus 2 radical 13 minus 2 radical 13 plus 4. So the square root of 169 is just 13 minus 2, so that's minus 4. They have the same thing, so that's minus 4 radical 13 plus 4. 4 plus 13 is 17, so 17 minus 4 radical 13. Biggest case with these is when you multiply something that by itself, radical 13, realize it's just going to be 13. Or the square root of, 169, which is 13 as well. Okay. So there's multiplying using the FOIL methods, and there's solutions that we probably had as well. Okay, so why don't you go ahead and give these a try, and I'll just put the answers up here in about a minute. I'll put some background music in. You don't have to look at my face. Give me about a minute. Go ahead. All right, so there are your solutions. The first one, you probably would have had 16 minus 4 radical through 7 plus 4 times the cubed root of 7 plus the cubed root of 49. You probably wouldn't have written it like that. Probably just went straight to there. And then the last one, difference of squares. The middle two terms are going to take each other out, kind of, and you could leave it written like that or just put r minus s. So there's multiplying. Now we're going to divide. So we're going to do what we call rationalize in the denominator with one term in the denominator. So we're going to look at dividing now and how you go about dividing radicals. So we've got 5 divided by radical 11 for a, and then that thing on the bottom, which we'll talk about in a second. So in mathematics, you can't divide by 0. You can't divide by decimals. You don't like fractions in the denominator. You also don't like radicals in the denominator. So what we have to do when we're rationalizing the denominators, we need to get that radical out of the denominator without changing the value of the expression. We can't just multiply things in there and change its value. So in order to do that, we have to essentially multiply by something that's equivalent to 1. If we take 5 radical 11 times 1, it's just 5 over radical 11. Well, it doesn't help me if I just multiply it by 1. But if I multiply it by something that's equivalent to 1, I still haven't changed its value, but I can get rid of that radical in the denominator. So what you do is you just multiply both the numerator and the denominator by just what's underneath the radical symbol. We don't care if there's a number out in front of the radical symbol. We just want to know, we just care about what's underneath that radical symbol. Now, if we do that, and keeping in mind that 11 and 11 cancels each other out, so it's really just 1. But you multiply top times top, that's 5 times radical 11 over radical 121. Well, radical 121 is just 11. So that's your solution. They're done. We don't have the radical in the denominator anymore, and that's what we wanted to do. So we got rid of that piece of it. And we don't care if there's radical in the numerator. That's just fine. So there's your solution. So in the second one, 5 radical 6 divided by radical 5. Radical 5 is in my denominator. So I'm going to multiply both the numerator and the denominator by radical 5. On the top, that gives me 5 radical 30. On the bottom, it gives me radical 25. Simplify radicals if we can. 30 is 3 times 10, so that doesn't do any good. So that's 5 radical 30. Radical 25 is just 5. There's our solution so far. But you'll notice that you've got 5 and 5 there. They're both on the outside. Those can cancel out, leaving you then with just radical 30. Which is nice when that happens. It reduces it down to its simplest form. Right? Imagine that. Okay, the next one, negative 8 over radical 18. Okay, we're just going to multiply by radical 18. Might be able to simplify this one first, but we're not going to. Let's go radical 18 over radical 18. So that leaves negative 8 radical 18 over, you've seen the last two examples, we just end up with what's underneath the radical symbol, right? So we're just going to end up with 18 here. So if we look at number-wise, 2 goes into both of them. So we could reduce number-wise to negative 4 radical 18 over 9. But we need to look at that 18 because we have to simplify it. So does 18 break down? Well, that's 9 times 2, 3 times 3. So radical 18, in fact, is 3 radical 2. So 3 times 4 is 12. So that would be negative 12 radical 2 over 9. But now you'll notice that 3 goes into both of them. So we would have negative 4 radical 2 over 3. And that's your solution. Could you have done that from that point right there and saved some? Sure, you could have. And had like 16, 18, 9, 3, 24. Negative 24 radical 2 over 18 and then reduced it from there. that does it for that one. Okay. Look at that, same answer. Okay. Now what if they have it like this? Oh, well, remember from the last lesson, or from a couple lessons ago, that this is equivalent to radical 8 over radical 45. And the negative kind of out front of that. Sorry, throat's getting sore. I need coffee. Now, you could, and that might be the easiest way to do it, is just say, I'm just going to do 45 and 45 here. There's another way to do this, but there's nothing wrong with doing this. You just get a big number. And that's fine. 8 times 45 is negative. Oh, it's actually not too bad. So you get negative 360 over radical 45. Radical 45 is just 45. But now we've got to deal with that 360. Well, that's just 36 times 10, and 36 is 6 times 6, 2 times 2. So this becomes negative, that's 6 times 5, I guess, 2 times 5. So this becomes negative 6 times the square root of 2 times 5 is 10 over 45. And then 3 goes into both of them. So 3 radical 10. That's 2. 3 goes into 6 twice. Over 9. 3, 9, no, 15. And that becomes your solution. So, I mean, you could have taken care of it a little bit earlier, maybe by taking care of the 45. You could have taken the 45 and made that into 3 radical 5, and then just multiply by radical 5 over radical 5. But you get the same answer any way that you do it. My guess is if we watch how they do it, that's probably how they did it. Yeah. Same answer we got. So either way, works out in which way that you decide that you want to do it, you can do it. And we, in fact, aren't going to do any questions like this one right here. So multiplying using the FOIL method, and then rationalizing the denominator is what you have for today's lesson. So hope everybody has a good rest of the day. Stay safe, and we will see you next time.